Hi everyone. So in today's video, as I mentioned in the previous one, we are going to start to work on refactoring our detector code using some thread methods, and we are also going to improve our tests. So first, let's start with the tests. What are we exactly? What are we really testing right now? So the only test we have is should start detector. If not, get started. This at least regarding the detector itself. So yeah, we are basically testing if we start. It's running, stop, it's running, it's not running anymore, that's it. So, what I would like to do right now as well is to ensure that, or let me ask a question, right? Let me go here, we copy this one, and I will say, what if here in my code I throw an exception? Throw new runtime exception. What if this happens? What should I expect from this? What I would expect is should continue running in case of an exception. That's what I would expect to happen. So if I start, I would expect this to run to keep running. So if I do this, then I will just, for now we are like doing this in a sleep of half second. So I'm going to ensure it's running, then I will do a thread sleep of 1 second just to ensure that the exception is going to be thrown, and I want stop, and I want to check if this is still running. Okay, let's see. Let's run the test. So you see that there is one exception here, but everything like seems fine. So the running is not being affected. So this logic here is not being affected by the exception itself. So the test may not be very precise, may not be very effective. Let's do another check. So let's say that, for example, let me see how many times I would. So if I have, let's say if I do here let's say 2 seconds, I would expect this detection to run at least 3 times, because if it runs every 500 milliseconds, this means that it could be able to run 4 times, right? It just starts and then half millisecond, more half millisecond, half second plus half second, 1 second, 3 and 4 times. But to be safe, let's say it's going to for sure run 3 times, or like let's say even 2 times, right? So let's create here a counter. So new atomic integer, because we are going to increment this inside the thread, and for every time there's a detection, I will basically increment and get, and then I will throw an exception. But every time this method is going to be called, this guy is going to be incremented. This guy is going to be incremented. So why am I doing this? Because after checking this, I also want to check if assertions dot assert equals. So I want to check if. So I would expect to have, or let me do assert true. I would expect this counter dot get to be higher than true, or higher than 1, let's say, because what I want to check is if there is one exception, this is going to run again, and this whole method is not going to be blocked, or like the detector is not going to be blocked, so there will be more detections after the first failure. That's what I want to check. So if the counter is higher than 1, that's already enough. Let's run the test again. It fails. So as we can see, we know that if we found 2 problems here. First one is our detector is not resilient. So if there's an exception, it basically stops. And second thing, our is running basically doesn't work, because the logic of it's kind of somehow broken, right? It's not connected to the fact that the application is, or the thread is really running or not. That's why I mentioned that we are going to change this, choose the thread methods. So first thing we are going to do, let's completely remove this whole idea of completable feature here. Why? I'm going to explain. So we are going to change this idea here of using this to use what we were using before. So we call executor service dot submit. Then we pass the logic we want to submit. Then we have the execution, which is just a feature. That's all fine. We are going to keep the execution here inside the atomic reference. But there's one small difference here. We are not going to be running the application or like this logic here based on this running or detection running, because we are also going to remove it. No, this is not going to remove, sorry. We are also going to change the name. So detection running, or let's say active detection. Doesn't mean that it's running or not. Or active detection. Detector. Execution. So active detector execution. So it's basically, yeah, we are not going to do our logic based on this. We are going to basically come and say, hey, let's get first the current thread, which we get from thread.currentThread, because this logic here is a bit agnostic from the thread itself. It doesn't know which thread's running until you really get it. So because this thread, the thread which is running this code, comes from the executor service, right? Which is like a pool, or has a pool of threads. So we basically get a current thread and we check if it's alive. If the thread is alive, we are going to keep running this while forever. Then we do here again active detector execution. We set execution here, all fine, and now we change the logic as well. So we don't do this here anymore, or in fact we do, like for this top we get this active execution, we get the process running, and then we cancel it, also fine, and is running, we are also going to get that here. And if it's not null and if it's not cancelled, that's exactly the same. Okay, so what else do we have to do? We did this small check here, right? So let's run the application again. Okay, still fails. So now we have to wait. This is failing on the same part. So now we have to do one thing. It's cancelled. Let me check one thing. Process dot is done. Let me do another thing. So let me debug the code first. I would like to check one thing before. Is running and is running. That's what I want to check. So I want to just check what's the state of our future after the exception is thrown. So here's null, all fine. Now we are going to check. So process running. So if I get that here, process running dot is cancelled. So that's false. It's not cancelled. Is done. True. So it says that this one is done. I think that's exactly what we need to check, because if it's done, it means that it failed, or because it could be cancelled. It could have been cancelled itself, because we asked for this to be stopped. So we asked for this thread to be cancelled, or this could have been done, and if you remember well, this is just done if the while is finished, or looks like if an exception is thrown. So if this and this, or process running is done. No, here is not negative. So we basically check if process running is equals to null, then it's not running, or if this is different from null and process is not cancelled, or process is done. So no, yeah, It's really negative. So if they are not cancelled nor this is not done, then it means it's running. So now we can check and run our test again. What's the problem right now? Let's check. Okay. How many times do we have? Now let's add a new breakpoint here. Counter, we got only one. Yeah, sure, because this basically failed and it's not running again. And by the way, I think this logic was kind of working before. Am I right? Am I wrong? Because we ran the test before and it was failing on another line, and I think I was a bit biased. Yeah, so this one was running fine. So even with this one, this cancel is somehow working. So it was my bad. I just confused that because I was a bit biased. But now thinking about it, why the counter is not incrementing? So as soon as the exception is being thrown, so this stops to execute. Yeah, and this guy does not run again. So the only thing we have to do, or we can do, is to do it here. And then we, for example, catch the exception here. We could catch everything like a trouble, because God knows it could be also hardware issue like memory thumb something, so we can throw like we can catch everything. Let's just print for now, and now I will run the test, and now it should pass. Yeah, I think it's just running so many times because of this sleep, because it's failing before the sleep. So let me stop and do the sleep before the processing itself. So I want to sleep and then throw the exception later. Exactly, that's exactly what I wanted to see. Perfect. So that's a way, right? One thing which we can also do is we can also add a callback here that says, hey, on failure, do something. So we can come and we can say, hey, final consumer of exception or trouble on error. But this starts to be, our code starts to be a bit ugly, because we have one consumer for processor and one consumer for throwable. So let's be a bit more object oriented, right? So let's create a type of object which we can use. So we have the processor. Let's create an interface called processor itself. So we create here a package processor and an interface called processor. So this interface is going to have two definitions, which is going to be void on detection, which is going to receive a detection itself, on error, going to receive a trouble. That's it, right? So now we are going to receive here a processor. We can also have like something here of t. Then we are going to receive here an item. So we can say it's a processor of detection itself. Okay, so let me also change that here. So processor, we have processor of detection, and here we are going to call processor dot on, not on detection, right, on item, or let's say on event, and we call it here event, on event and on error. On event, we handle it, and here we basically call processor dot on error, and we call the exception. Okay, fine. So let's refactor our code, right? Where is this breaking? So when we go to the test, to the app, we have it here. Let's create now our implementation, which is going to be fake processor. This is going to implement our processor of detection. We don't need to make it fake, right? Let's just call it detection processor. I will implement the methods, and let's come here to our configuration. What we do is basically the same here. We are going to copy. So on each event, we are going to run this. We need to have the repository itself, which is going to be that. So here we are going to have our service. We have our repository, constructor, fine. And what else? Also the properties. We need the properties. Yeah, that's not public. Let's make it public. So we also receive the properties. Okay, what else? So detection is here. We get the detection, we try to register it, and if there's an exception, we're just going to also again throw it's like just print stack trace for now. Okay, what else? So here we remove this, and we will pass the new fake or the new detection processor, passing the repository. And in fact, we don't need to do that, right? We need to basically get the detection processor here. Here's in Spring, so sometimes I forget about it. Okay, so we have the processor here. All fine. What else? Here we can remove it. Don't need it.